often, hear from uh, our, leadership and management, and when we kind of do this work, is how can we find and evaluate things faster, right? Like, okay, if you, take your car out and or take a platform out and go and run and you get the data out of it, you spend some time, the data gets ingested, you review it, and then you're like, hey, there's a perception problem. Okay, great, but we had the problem. Okay, how could we have prevented that from happening before? And I'm not necessarily talking about, I think we mentioned some of the stuff here about moving to the left, using simulations and offline testing. Excellent, right? That's how we can stress test. That's where we can get millions of, exposure data from the platform. But is there any way in which we can do, sort of predictive modeling to say that, look, this is the state of our system. We know that these are the kind of problems we've had before. What inputs we can put into some sort of modeling this behavior so that when we know that we land these changes right on your main line, what is the performance of your system going to be? So a little bit of like crystal balling out the change, its impact, and how we can improve the performance. Either of you, Melinda, if you want to go first, or Nick, like what has happened in this field so that there's more data sciencey, predictive analysis for performance.
I'm happy to jump in. Yeah, certainly at Motional, at my time at Mobility, this was the name of the game. How do we do exactly what you've suggested here? How can we kind of predict either places we expect there to be failures or gaps in our system, and also kind of the inverse almost of, if we do make this change, what do we actually expect the impact on top line performance metrics to be? That's a really powerful thing to be able to do. And of course, that's like you mentioned, leadership at Motional, I'm sure at all companies, that's what they really want to know, right? What changes are we making, and what do we actually expect the outcome to be? And so that's certainly something, lots of people at Motional are working very hard on kind of answering and improving the way that we do try to answer that question and predict that outcome. And we do it by leveraging a lot of the historical data that we have collected, kind of analysis and kind of generalization of our system performance into kind of the capability space. So thinking about, kind of key capabilities when we're thinking about what types of scenarios and situations does an AV need to interact with, and what does our test coverage look like? What does our, system performance look like across those? And then kind of combining those and correlating those, using various different, predictive modeling techniques to then try to answer the questions, everything, right? What's the impact on top line performance metrics going to be? Where should we expand our testing, both in simulation and on road, so that we can, actually expose our system to more of the problems, the things that we need to do, and all sorts of different things. Really trying to predict that is kind of where we're going next. And I think
that's a hard problem.
Oh, absolutely. Right. Yeah, I mean, there's teams of people at Motional kind of just working on this, all completely offline, right? None of this is the predictive decision-making tools that we use online. This is all, using offline data and trying to answer that about our system.
Right. I think the statistical, your ICA, PCA, kind of, putting your different variables together and kind of figuring out. It's a very interesting, like a field in itself, right? When you have a bunch of data points and you're kind of predicting what would be the output of a change on top of, certain state of your system, becomes very interesting. I do want to double click, Nick, but before I go there, any thoughts on this like predictive modeling using data?
Yeah, I definitely think this is the way that we all have to go. I guess just a couple comments. I think a couple of other things just to add on to what Melinda said is that, yeah, I think that within like autonomy groups, I see this maybe within certain subsystems. So certainly perception for their own use case is like, actively trying to build things to be able to identify, sort of trends or known issues and not be in a reactive state, but kind of predict how performance will be. Certainly, a motion planning system might behave in that way. I think one of the tricky parts is how you move that online. As Melinda said, it's like a really difficult thing. I think in a perfect world, like the system would just be like, oh, I know I'm bad here, and I'm just going to get better. I'm going to learn from that. And I think we're a ways off from that. But I think the point that we're after here is that, retroactive data analysis is is valuable, but it's slow. And it might be the right thing to do as we, at a smaller scale, but as you start to really scale your fleets, the number of vehicles on the road, whether it's through ride sharing or trucking, you really have to get to, start to work in like a very data-driven way to figure out like where are our weak points, what are the things that we maybe don't know yet, how do we deal with that uncertainty. I think through the simulations, can we go ahead and proactively generate some of these edge cases that maybe we've never seen, but we anticipate might happen? I think that's a really important part of simulation, is saying, hey, we've got this whole set of thousands of variations of the same exact intersection set up, and like we can use the past performance to help figure out and simulate what the future possible risks are. So yeah, I know, like Melinda said, Aurora also has a very large data science team, both and also a lot of our subsystem teams are kind of working on this for their use cases as well.
Yeah, no, very cool. When I used to be with Aurora, right, and like we used to work on a bunch of these data science problems, and I'm sure the scale and the nature of these problems has evolved in the last so many years. No, I think taking a step back, right, the maturity of your system as a curve, and complexity of the problems as another curve, right? I think they're kind of inversely proportional to each other, unless we are doing something really wrong in that setup, right? As you kind of build your system towards a launch and product becomes more mature, the kind of problems that you're going to get are hopefully getting more predictable in a way, but they are also, kind of a little bit unexpected, because if they're expected, you might as well have solved them, before. Right. So the volume of these problems and the complexity, I think that equation changes drastically as you're kind of getting close to a, sort of a product ready for a, launch. And I think the important thing which you both mentioned, and I want to double click on, is the test coverage and ODD analysis in a way, right? I mean, operational design domain, for those of you who are not completely aware, that's basically setting the constraints of your environmental operations, from the infrastructure to weather to your capabilities to whether you can do a traffic light, roundabout, left turn, right turn, all the different sort of, things that you can imagine, right? That basically becomes a founding framework to understand, where we're going to launch or where we're going to even drive before the launch, and then, prepare for the launch, in terms of perfecting those capabilities.